Morning class, welcome to our Science Google Classroom. Today is the 7th day of April 2020 and it's Tuesday. Now, I have here picture. Do you know what is this class? Okay, can you write your answer in a paper or in your whiteboard? If you have it with you, I'm going to give you 20 seconds to do it. Okay, time is up. Now, for those who put the correct answer in here, the correct answer is light bulb. Did you get it correctly? That's amazing. Now, our lesson for today is about how does electric charges flow. If you have your book with you, you can open it on pages 378 to 379. Now, these are our objectives for today's lesson. Number 1, explain how do electric charges flow. And number 2, compare and contrast series from parallel circuit. These are our words of the day. First, we have electric current. We have also closed circuit, open circuit, parallel circuit, and series circuit. We are going to discuss what are the differences of these different words. For our introduction, how does the electrical energy in a battery get to a light bulb? So I have shown you a picture a while ago. I said it's a light bulb. To study how electricity moves, scientists build models called circuit. Electric charges travel through different materials at different speed. Now we will focus here about circuit. So what is a circuit? When you say circuit, it is a loop or like a path where electric charges flow. So that is a pathway where electric charges flow. It's like a road where a car will pass so that they can go to their destination. In electricity, there is also what we call electric circuit where will electric charges flow or travel. Now, what is an electric current? When you say electric current class, it is an electric charge in motion. You know, what do you mean by the word motion? Motion, in other words, is movement or it's moving. So, how do electric charge move is what we call electric current. Is it clear, class? Okay. So that is what we call an electric current. Now, there are 4 types of circuit. So we have closed circuit, open circuit, parallel circuit, and series circuit. What are their differences? Before we are going to discuss the differences of those circuits, we are going to discuss first what are the different circuit symbols. So these are symbols or circuit symbols. We have a lot, but I'm going to show you only 3. So we have here the symbol for resistor. When you say resistor, from the word resistance, it is not allowing the flow of electricity. And we have here the switch, the one that you're pressing, switch on, switch off, when you are watching when you want to switch or to use the air conditioner, or when you want to use the light bulb, or sometimes in your fan there's a switch in it. So that is what we call switch. So there's what we call a switch off and a switch on. When you switch it off, the wire will rise or it will go up, and it's like it's broken, so there will be no continuous flow of electricity, so the gadget or the appliances will not work. That's the reason why when you switch off the light, the bulb will not light up, because the wire here that is connected in this part is broken when we switch it off, and that is what we call an open switch. And when we say switch on, when you switch on the light, for example, you press the switch, then you just press it on, and then the light bulb will light up, because there is a continuous flow of electric charge or electricity, and that is what we call a closed switch. And another circuit symbol is what we call energy source. So this is the symbol for energy source. When we say energy source, where does the electric charge came from? Where does it came from? That's, for example, it came from a battery, or maybe it came from a solar panel, it came from a generator. So those are example of energy source. Now, going to repeat again, I said a while ago, this is an example of closed switch and an open switch. When you switch it on, there will be a closed switch, and there is a continuous flow of electricity. That's why when you switch it on, the light or the bulb will light up. And when you switch it off, there is an open switch, because of the flow of electricity will be broken. So I'm repeating this one because this is important to identify what is an open and closed circuit. Okay, so this is another picture. As you can see, one is broken and one is continuous. This one is a flow of electricity that is continuous. Okay, now this is an open circuit and a closed circuit. Compare them. Compare the flow of electricity here in an open and a closed circuit. Compare them. I will give you, look at it, I will give you 20 seconds to write your answer now. Time is up. Okay. Look if you got the correct answer. So I'm going to explain now what are the differences between a closed circuit and an open circuit. So when we say closed circuit class, it is a circuit in which it cannot have any break. So it should not be broken, and in closed circuit, there will be a continuous flow of electricity, because in this circuit, it is not broken. As you can see here in this picture, here in a closed circuit, that the flow of electricity here is continuous. It is not broken. So there will be a continuous flow of electrical charges in here. But when we say open circuit, it has at least one break that interrupts the flow of electric charges. Interrupt means it's broken or break or it's cut. Okay, so as you can see here in an open circuit, that there is a break in here in which this wire did not touch this wire, in which the flow of current in here is not continuous, so it will not work. So these are the differences between a closed and an open circuit. I'm going to show you more example for you to understand it more. Okay, So this is a closed circuit and this is an open circuit. As you can see that in a closed circuit, there is no break and the flow of electrical charges here are continuous. And here we have here an open circuit. See, there is a break in here. As you can see, of course, the flow of electricity here is not continuous or it is broken. That is what we call closed and an open circuit. So another one, this is a closed circuit. You can see the bulb here light up because the flow of current is continuous and there is no break of electrical charges. And this one is not light up because there is a break in here. So the flow of electricity here is broken. So that is the differences between a closed and an open circuit. Now let's proceed to a series circuit and a parallel circuit. Both of these class are closed circuit. It depends on how do they make the path or the loop. So these two here are same closed circuit, but how do they make the loop or the path are different. In a series circuit, here the electric charge can flow only in one path. As you can see here, this is a series circuit. Look, the flow of electricity in here is only one way or one path. Okay? And in a parallel circuit, it has two or more paths for electric charges to flow. So here there is one path in here and then another path in here and then another path in here. So there are three paths in here. So what makes them different? So I'm going to explain it more. For example, I have here a parallel circuit and a series circuit. So we have said that a parallel circuit has at least two or more paths of electric charge. Here, there's only one path of electric charge or the flow of electricity. So what makes them different? Here, for example, if this light bulb here is broken, because it's a parallel circuit, there are many paths, two or more paths in it, still there will be a continuous flow of electricity. Meaning that even this one here is broken, other two light bulbs here will work. Because the electricity will flow this way and the electricity will flow this way. Meaning still, if one is broken, two or more appliances will still work because there are more than two paths of electrical charge. Here, we have here a series circuit. There's only one path of electric charges here, meaning that if this one is broken or busted, these two here will not work. Why? Because it's broken here. There's only one path. The electric charge will stop in here. There will be no continuous flow of electricity, which means that because it has only one path, if one is broken, and the two will not work. So all of them will not work. Unlike here, if one is broken, still the two other will work because it has another path or flow of electric charge. That is the differences between a parallel and a series circuit. Now identify if this is a series or parallel circuit. 5, 4, 3, 2, 1. This is a series circuit because it has only one path. Next. 5, 4, 3, 2, 1. This is a series because it has only one path. If this will be broken, and then of course these two here will not work anymore because there's only one path of electricity. And here, 5, 4, 3, 2, 1. This is a parallel circuit, and if this is broken, still these two will work. because it has two or more paths. That's it, class. Bye-bye.